This is a 1969 Mustang, and this is a 1974 Mustang. What the heck happened? Well, emissions standards happened. New emissions regulations put in place during the 70s meant that car makers had to cut down on their ozone depleting exhaust by 90%. And when that happens, you go from buff pony to My Little Pony. But the Fox Body, it got the Mustang back on track. It showed the world that you can make an all-American V8 sports car while still keeping the EPA happy. So how did Ford do it? How did they bring back the 5.0 badge, revive the Mustang, and keep the EPA off their backs? Well, today, we're gonna look at 3 ways Ford re-engineered their Stang, starting with its surprisingly aerodynamic body, and then how they used 70s computer technology and the fabled 5.0, and lastly, the misunderstood and underappreciated catalytic converters. Don't cut those things off. They're actually pretty good. Let's go. Let me address the big old elephant in the room. When you think about Fox bodies, chances are you're not thinking about aerodynamics. You think of in-traffic Bernies, menace to society, and Florida. But in the late 70s, Ford was starting to experiment with aerodynamics in their production cars. And the reason was, well, they had to. When you're forced to cut emissions, there's only a few ways that you can tackle that problem. And one of the more obvious ones is, well, you make your car more aerodynamic. Fox Body was based on the platform of the Ford Fairmount, but with a wheelbase that was 5 inches smaller to make the car more nimble and, more importantly, lighter. Less weight means you burn less fuel to move it, which means less emissions. And not only did they make the car lighter, they slanted the front end backwards and raised the cowl point of the hood to give it more of a wedge front end. And that shape allowed the car to cut through the air better. And the purpose of all that was to have a drag coefficient that was as low as possible. Now, drag coefficient is a measurement of how much an object or shape is affected by a fluid. And like all great dimensionless numbers, we can actually calculate it using the drag equation. I know school's out for summer, but stay with me, okay? Now, the area is the surface area of the front of the car. The velocity is the speed at which you're moving at, and the fluid density, in this case, is the density of air. That's the fluid we're moving through. We're moving through air. You might not know that. We're around a bunch of air right now. So if we were in a controlled environment, like say a wind tunnel, we could control the air density and the airspeed, and we can measure the drag force. That's the force pushing on the car due to air. And once we have all those numbers, we can plug it into our equation and determine the car's drag coefficient. Now, what does all any of that science math stuff have to do with fuel economy? Well, the more drag there is, the harder the engine has to work. It's pretty obvious, right? And as you accelerate, the air velocity hitting that car increases, and the force pushing on the car gets exponentially stronger. Look at our drag equation. The V in our equation is squared. That means exponential. So even a little change in the shape of a car can have a significant effect on drag. Now, we've all stuck our hand out the window to feel the air pushing our hand back, right? You feel more force on your hand when it's shaped like this rather than like this. So you have a more aerodynamic car, the engine has to do less work, and that means it uses less fuel. Now, in the case of the Fox Body, its new shape with its bucketed headlights inside that slanted grille, quarter window louvers, and that wedge style hood got its drag coefficient down to 0.44, which doesn't sound all that great, but at the time, that was the lowest drag of any American Ford car ever built. Now, the Fox Body actually had this same drag coefficient as Ford's Le Mans winning GT40. That's pretty cool, because if you were to compare these two cars, 9 out of 10 people would think the GT40 would have a lower coefficient of drag. But now, you'll be the 1 out of 10 person who knows that they're the same. So that's the first way Ford tackled some of these emissions problems, making the Stang slide through the air with some curves on it. The next was some fancy tech called electronic fuel injection. Now, the 1986 Ford Mustang GT was the first ever fuel-injected Mustang. It used a computer that controlled the amount of fuel being sprayed into the injectors. That's what electronic fuel injection is. There's not a car out there today being manufactured in 2020 that I know of that doesn't use EFI. If you know one, throw it down in the comments below. But before we can really explain how Ford engineered EFI into the Fox body, we have to look at what they were doing before. They were using carburetors. Oh no! Up until 1985, Ford had been using carbs for getting fuel and air into the Mustang cylinders. And they had this engine, you may have heard of it, I don't know if you have, I have. It's called the 5.0, and it was the engine that was going to bring back the horsepower into their pony car. Problem was, their existing carburetor setup wasn't cutting it. Ford tuned the engine normally, it would be so bad on gas mileage that you get hit with this gas guzzler tax. That would be way too expensive to sell. And then if they detune the engine too much, the car made no power. So what's going on with this carb and why is it so finicky? Now, a carburetor is really just a fancy tube, and I'm greatly oversimplifying it, but it makes understanding how they work pretty easy. Now, there's a plate inside that tube, it's called a throttle plate, and that controls the amount of airflow through the tube. Now, the shape of the tube doesn't have a constant diameter across its length. It actually narrows towards the center and then opens back up. It's called the Venturi. And the reason there's a Venturi is because when air flows through it, it creates a difference in pressure, a vacuum. And you might have heard of the Bernoulli principle and the Venturi effect. This is what's allowing a carb to work. Air flows down the tube, creating a vacuum, and it's this vacuum that draws in fuel through various holes, also called jets, inside the carb. And adjustments can be made on the carburetor to fine-tune how much fuel gets mixed in with that incoming air. It's really an ingenious process, but here's the problem. While a manufacturer or auto shop mechanic or your dad can adjust a carburetor very precisely, they can't adjust it while you're driving. And things like the engine RPM, the throttle position, the conditions of the piston rings, and yes, even the type of exhaust you're running affect the carb jetting. And not only that, carbs can't take into account changes in air or fuel temperature or atmospheric pressure. So anything outside of perfect conditions, a carb will be delivering a less than perfect mixture. So the Ford engineers had reached their limit on how much power they could make and how much emissions they can control with the carbureted system in the 5.0 engine. So what did they do? Well, the engineers decided to use this technology called electronic fuel injection. Boom, boom, boom. Now with EFI, it's just a nozzle spraying fuel when a friggin' computer robot tells it to. And it has the ability to change fuel volume on the fly. So in 1986, Ford developed their first fuel injection system for the Fox body, the SEFI system, which is sequential electronic multi-port fuel injection. They missed a couple letters in there, but engineers aren't good at naming stuff, and they're really not good at engineering stuff a lot of the time too. As an engineer, you can say that. We can make fun of ourselves. And the brains of this SEFI used in the Fox body was a very sophisticated computer at the time called the ECC4, Electronic Engine Control 4. It was their fourth version. This thing was built by Intel using a 16-bit processor with only 1 kilobyte of RAM. Okay, say your computer has an 8 gigabyte RAM stick. That's 8 million times more RAM in that little stick than this whole entire computer setup had. It's just, you know. So that computer controlled 8 injectors, 1 per cylinder, and the distributor that fed ignition to the 5.0. So how does that work? Well, stored on that massive amount of memory is a fuel map. And a fuel map is just a pre-programmed table that engineers write based on various sensor data. And it looks something like this. Now you have your engine RPM and you have your engine load. And for each point, you have the amount of fuel that the injector is squirting in. So this fancy dancy computer uses that map to tell it how much fuel and for how long the injector needs to squirt. And with sequential fuel injection, it fires each injector separately just as the intake valve is opening. And this helps EFI give your engine only the fuel it needs when it needs it. That means no fuel is wasted, and that means the car can be more fuel efficient. You get better emissions, and in fact, you get better performance. And fun fact, that efficiency actually doesn't have to mean better miles per gallon. And in fact, the Mustang was so efficient that Ford sacrificed a little bit of that efficiency to dump more fuel into the engine along with more air. And as we all know by now, more air plus more fuel equals you got dang right more power. But like any new tech, the initial reaction to EFI was not good. Car guys, they're like, dude, electronics, I don't know. Am I gonna be able to modify my engine? Obviously, they were wrong. The Foxbody's EFI showed that making power using fuel maps and computers would be the way of the future. Freaking Foxbody, man. So the Foxbody brought the pony car into the modern era with aero and electronic fuel injection. But those two things don't cut down on 90% of emissions. To do that, you need not only engineering, you need chemistry. Now, luckily, there was this hack, this magic box that scrubbed emissions called a catalytic converter. All cars made after 1975 were required to have them. Inside a catalytic converter is a honeycomb of material coated in rare metals that neutralize those exhaust gases. And when heated, these elements inside become a catalyst, and they speed up chemical reactions of the oxidizing exhaust gases, converting that gas to something less harmful, hence the name catalytic converter. So how does it do this? Well, it's a two-step process. So those rare metals inside the cat are platinum, palladium, and rhodium. Now first, platinum and rhodium pull oxygen off nitrogen oxides, that's the bad emissions, so that nitrogen can be shot out as N2. That's a harmless gas that makes up 78% of our air. Now the second step, palladium, is used to take that free oxygen pulled off from the first step and help bind it with carbon monoxide. Again, carbon monoxide, another bad emission, to form CO2. Not only that, it also helps oxidize any unburnt hydrocarbons by throwing a bunch of oxygen on them. That's what oxidized means. Now the Foxbody fans know if you want more power out of your Mustang, you should cut those cats off. The cat is a bottleneck on the exhaust flow. The more the emissions need to be reduced, the tighter that honeycomb needs to be, and the more back pressure gets built up between your cat and your engine. Your engine needs clean air in the cylinders, and if exhaust gases are backing it up, it means the exhaust gases can't escape quickly enough to make more room for more clean air. Just, everything gets bound up in there. But here's the thing, don't go cutting off your catalytic converters, because this was in the 70s. So nowadays, cats are super efficient, and actually they can help give you more power. And really, we don't want all those harmful gases getting spewed out into the air. Think about your kids. You don't want them breathing that stuff in. It's nasty. The 1986 Foxbody may have made less power on paper than a standard GT of 1969, but it had the same 0 to 60, it had a higher theoretical top speed, and it got 18 miles per gallon. It hit that sweet spot of power, cost, and fuel efficiency that Ford actually still targets in their GT today. Now the Foxbody Mustang, it wasn't the first car with cats or that used aerodynamics or electronic fuel injection, but because Ford changed the muscle car formula and added these innovations to their Halo pony car, it's probably the reason the Mustang is still around today. Heck, they have a huge cult following. There is a reason for that. I want to be a part of that Foxbody cult. I know James wants to be. He wants a Clipto Green Foxbody. I also want a Clipto Green Foxbody. So if you know where there's two Clipto Green Foxbodies, be in the comments. Tell me where I can find it. I'll actually be in the comments for the first hour. So come hang out with me. Hit me up on Instagram @Jeremiah Burton. Hit us up on Donut @Donut Media. Bye for now.